And my topic is translation technologies. This is an introductory lecture that I give to first-year undergraduates, and it has one very major objective, which is to introduce translation technologies, but particularly to make a very important distinction between machine translation, which is translation done automatically by the computer, and computer assisted translation, where the computer just helps in the process. So there's the first real slide. This is a machine that goes back to 1954, and it was the computer on which the world's first machine translation experiment was conducted in all those decades ago, and it succeeded in translating just 60 sentences from Russian into English. This was known as the Georgetown experiment, and it was a collaboration between IBM and the University of Georgetown. And its main purpose was to convince the US government to keep funding research into machine translation, automated translation. And on the bottom left of the slide, you can see the kind of punch card, a Hollerith card, that was used to program this beast. And the phone you probably have in your pocket has probably millions of times the power of this enormous 1954 computer. So research continued, but people realized that translation was harder than they thought. And in 1966, a famous report was issued which said that really machine translation research wasn't worth funding. It was too difficult and the results were too poor. So the ALPAC report was done by a committee in the United States called the Automatic Language Processing Advisory Committee. And it basically said that the government should stop funding machine translation research and should put money into basic linguistics instead. And the reasons are, been thought that translating was very much like code breaking, which is an activity that had really been very prominent in the Second World War. So the idea was that you could simply decode Russian into English, but that didn't work for reasons that most of us are familiar with. Natural languages are not like codes. The relationship between the code and the message is not one-to-one, because every source language sentence can have very many potential correct translations. So there's no such thing as just the one correct decoding of the source language. Something else we all know very well is that natural languages are very different. Human languages, Chinese and English, have very different forms. They're not the same form. They're not isomorphic. And language is full of ambiguity, which is not a problem for us humans because we can tell from the context which meaning is intended. But the poor old computer really struggles. It's very hard to give a computer a sense of context. So as a consequence of the ALPAC report, machine translation funding in the USA pretty much stopped, although it carried on in other countries. And instead, the attention shifted to what they started to call translation assistance tools. So let's look at what a computer can do to assist the translator, to help the translator in her or his work. So people started to wonder, well, how can I use this developing machine, this increasingly powerful computer to make translation quicker, more efficient, more reliable, and that has a lot to do with consistency, translating the same thing the same way every time. And of course, if you could do all those things, you can also make it cheaper, which is very important. So a really important paper by Martin Kay, published in 1980, set out to define what he called the proper place of men and machines in language translation. And one of his starting points was that machine translation, automatic translation, was definitely not the proper thing for machines to do in those days. So in Kay's paper, he started to imagine a scenario where the computer would do parts of the translation process, but the decisions would still be made, all of them would be made by the translator who's working the computer, who's using it. He did consider that gradual enhancements, as he put it, so improvements step by step, might eventually lead to machine translation. So machine translation wasn't impossible, it was just a distant goal. And the background to Kay's paper was that word processing in the 1980s was becoming very widespread, and gradually things like electronic dictionaries were becoming available, originally on CD. And then, of course, as the decade advanced and the 90s began, the internet era came along. So all those things made using computers to help the translator much easier. So the main thing that the computer is used for in this role is managing repetitions, what the Americans call leverage. In British English, we call it leverage, but the standard pronunciation in the business is leverage. What do we mean by repetitions, and what do we mean by leveraging them? Well, if you imagine a car manufacturer produces a model, should we call it the 2019 model of whatever the car is, and the car is going to have a user manual, and the manufacturer is going to want to translate that user manual for marketing the car abroad, to sell it into international markets. So there's a big translation job of turning that manual into probably many other languages. Now along comes the 2020 model, and it's got a few tweaks, a few added features. It's a little bit different, but mostly it's the same. Its manual is going to be slightly different, but mostly the same. So how do you avoid retranslating a second time the whole of the manual when much of it, perhaps 95% of the text, is going to be the same? So that's one question that the computer can help to solve with a component called translation memory. Translation memory, a database that remembers translations that you made before. The second question, we've already mentioned the word consistency. How can you ensure that the same word or phrase is translated every time the same way? And a particularly tricky case, imagine now we have a much more complicated machine, which is an aircraft, which has a really huge service manual. You can see the size of it there with all those volumes of content, of text, and you need to translate that. Now you're going to need a whole team of translators to translate something as big as that in a reasonable time. But the big question is, how can you make sure that they translate consistently? So the answer is to use the computer as a tool, and the acronym for that has become CAT, and people have played around with CAT. CAT stands for Computer Assisted or Computer Aided Translation. And here we have some little graphics that people have thought about. The top one is the cat on top of the computer working it. The bottom one is the logo of a research project funded by the European Union called CAT, which was an attempt to make a more advanced form of CAT tool. But in any case, obviously, CAT has really nothing to do with cats. This is just a diversion, a graphical diversion, but people like the idea, and the word CAT has really taken off. So what is a CAT tool? Well, it's a number of components in your workstation, your computer workstation. The first one I've mentioned already is the translation memory, often abbreviated to TM. And the TM stores translations. It stores source and target sentences, or more correctly, segments. So every time you translate a sentence, the original language and the translation of that sentence are linked together. They're aligned in a database. And what that means is when you find a similar sentence in another translation, perhaps next week or next year, it will find the translation for you and give you the opportunity to use it again. The second component is a term base or terminology database, often abbreviated to TB. And the term base stores terms. It's like a dictionary, but a technical dictionary that you can add terms to, depending on the domain you're working in, the kind of text you're translating. And the final component then, the third component of a traditional CAT tool, is an aligner, an alignment tool that does the job when you have existing translations. So you have translations that you didn't perform in the CAT tool. You can use the aligner to join the source and the target text together and line up sentence by sentence. So again, it's nothing to do with our feline friends, but it is a very useful tool for translators. So the basic way a CAT tool works is shown in this graphic here. Starting from the top, we have some existing translations. I've just mentioned the alignment tool. So these are translations that somebody did, it might be yourself, before you use the CAT tool. And the alignment tool then can link those together, align the sentences, link the sentence, source sentence, target sentence, one at a time through the document, and store it in a translation memory. That's the disk in there. It's notionally a disk. The second thing you can do with your legacy translations is to extract the terminology from them, the specialist vocabulary that you're going to store in your term base. So this means that when you start a new translation project down here, and there's the source text, the human translator has got these two tools to help her or him do the job. You've got the translation memory that will tell you if a similar sentence has been translated before, and if it has, it'll give you that previous translation. And you've got the term base that's going to look up the terminology as if it were a dictionary and provide the terms so that you always use the same term every time. That's the consistency element. The term base gives you terminological consistency. So this is what a cat tool looks like in action, and this is one that we teach in our master's programs. It is currently the world leading cat tool, and it's called STL Trados Studio. And I'll just explain a little bit about what this rather complicated window shows. This is the working environment of the translator, the editing window. And the job that's partly underway here is to translate this little English text in the left-hand column here into German. So here on the right, you've got two sentences that have been done. And, or rather, the first one has been done. The second one is underway. And the red box, the outline, the red outline there is the translation memory lookup window. So just to explain what's happened there, the translator has moved on to this second sentence here, finding a location for your photo printer, and the machine has automatically looked in its translation memory. It's looked up this sentence and it's found two that are not the same, but are quite similar and are similar enough to be useful to the translator. So what the translator has to do is decide whether to use one of those proposals, and if so, which one. And then if they decide to use the proposal, and the translator here has gone for the first one, because you can see it inserted there in German, the translator then needs to know, well, it's not an exact match for the sentence I'm translating, because there's a word that's different. So the sentence in the translation memory includes the word suitable, finding a suitable location for your photo printer. The sentence the translator's working on doesn't contain the word suitable. So the machine is smart enough to show the translator that he or she needs to find the German word for suitable, which here is geeignet, and delete it. And if the translator does that, the rest of the sentence will be an accurate translation. So the translation memory tool has not found an identical translation, a perfect translation, but it's found one that's good enough to be useful, and it's shown the translator what needs to be fixed to make it a good translation. And that's basically how cat tools work. And it's showing with this percentage figure here, it's showing that it's not an exact match. It's what we call a fuzzy match. It's an inexact match. And it reckons that it's 91% accurate. It corresponds approximately 91% of the time to the new sentence that the translator is working on at the moment. So that's how the translation memory works. It's a window that offers you translation proposals as you're working as a translator. The other component, and I've highlighted that here with another red box, is the terminology lookup. And what you can see here is that the system has automatically looked up, we're still in the same sentence, we're still working on sentence 2. It's looked up every word in that sentence automatically in a terminology database, a term base, and it's found photo printer. And you can see that that word is in the term base because it's got this red bar across the top. And this window shows you what the German translation for photo printer is that is contained in the term base. So these are the two tools, the two components, the main components, translation memory and term base, that the cat tool provides to help the translator with their work. And these, obviously, this is quite a complicated looking interface. There are lots of menus and buttons and icons and so on. So these tools take a little bit of training. They take some time to become familiar to you and second nature. And that's why we spend a lot of time teaching these tools in the MA courses, and indeed in our BA courses, we use different tools. Just staying with the term base, this is an example of a term base, again from the SDL company, SDL Trados. This is their multi-term term base. And this is the kind of term base that was being used in the previous slide. So when we had the lookup there, this is a window that's pulling data out of a term base that is like this. And this is a separate application. Now, the nice thing about multi-term is that it's very flexible and very powerful. This is an example of a student project, in fact, that was done a little while ago. And you can see that it is a bilingual term base with English and, in this case, Spanish. It's on the subject of wind energy, wind turbines. You have a list of English terms down here on the left-hand side. And every time you click one, the information in the term lookup window changes, and you've got a lot of sophisticated information here, including a picture, hyperlink references to show where the picture came from. You've got English, you've got Spanish translation, you've got examples of the term in Spanish, you've got some semantic structural information, you've got the gender, awful lot of information that you can capture in a term base. So it's a really important tool. And there is a professional role called terminologists. These are people who build and maintain terminology databases. So that's really the main part of the lecture. I just want to look forward though and come back to the subject of machine translation. This is a report that I've listed in the references at the end. It goes back a few years now, and it was then looking forward to where we would be in the translation technology domain. And the first thing it points out is that machine translation research did not stop in 1966 with the ALPAC report, but machine translation systems became commercially available in the 1970s. The trouble was they weren't very good, and they weren't really usable except in niche applications. So this Meteo one was a Canadian system that specialized in translating weather forecasts between English and French. A big date was 1978 when the European Commission installed the Sistran machine translation system and also started its own development project called Eurotra. In the 1990s, we saw the beginning of statistical MT, machine translation not done by linguistic rules, but by querying vast databases of text for statistical correspondences between languages. And that also corresponds with the World Wide Web, of course, which is the essential corpus that's necessary in order to do statistical machine translation. Google Translate, which in Europe we use and the States we use an awful lot, was launched as long ago as 2006. And then in 2016, we saw the beginning of neural machine translation, which has led to a great increase in quality. And the TAUS report, TAUS stands for the Translation Automation User Society, and it's a think tank for translation technology. This TAUS report reckoned even 4 years ago that 99% of translation worldwide is done by machines. And TAUS predicted the arrival of what it called fully automatic useful translation by 2030. Well, I think for some languages, particularly European language pairs, that was extremely pessimistic, because I think we already have that in 2020 for language combinations like English and French, the ones I deal with. And I'm not going to explain this diagram, don't ask, please. This is a diagram which tries to represent how a neural machine translation system turns a very famous English sentence a long time ago in a galaxy far, far away, at the bottom there, into French. The thing about neural machine translation is it's very, very hard to know what it's actually doing, but it does work. And it's now a tool that we use every day as translators, and it can also be incorporated into our CAT tools. So my initial distinction between CAT tools, computer-assisted tools, and machine translation, automatic translation, is now well on the way to falling apart. The two technologies are coming together thanks to the high quality now that's available in neural translation, neural MT. That depends very much on the language pair, of course, and I understand that Chinese to English is not as good as French to English because the languages are very different, but it is improving. So that is the end of my lecture. I'll leave you with a few references on the screen there that you might want to, some of them might want to look up. The third one down, Hutchins and Summers, is very interesting as a historical account of the early days of machine translation, if you're interested in that topic. The last reference is to the Taos Translation Technology Landscape Report that I showed you 2 slides ago. Well, thank you very much for your attention.